Differential equation is one such topic in JEE preparation that, if done right, can guaranteedly give you one question correct in JEE Mains exam. In fact, I consistently have recommended students to prepare this topic even if they are not preparing the whole of calculus. All you will require is basic level of integration knowledge in order to get the question right. So in this video, in order to make your life easy, we'll systematically start with weightage of differential equation in last 4 years. Then we'll go into and check what the JEE syllabus says. Then we'll actually understand what JEE syllabus is through mind maps. And then we are going to understand those 12 problem types in which I have divided this chapter into. But before we start this video, there is a do, there is a don't. The do is, when you are watching this video, do make notes, do solve questions along with me. The don't is, this is not meant for a person who is just starting differential equation. This is meant for a person who has brushed up the basics, knows the concept. Then if you watch this video, you are really going to enjoy it. So without any further delay, let us start with it. Now, if I look towards the syllabus comparison, you can clearly see that from 23 to 25, there has been no change in the syllabus. Ordinary differential equation and their order degree, this is the first part that is already in the syllabus. Formation of differential equation remains the same. Solution of differential equation by variable separable, that is also there. Homogeneous equation and linear differential equation are also part of the syllabus. So fundamentally speaking, there is no change in the syllabus. Now if I look into the mind map, you can clearly see that when we start with differential equation, the discussion will start with basics, wherein we will understand what is ordinary differential equation and what is partial differential equation, how to find order and degree. Then we move towards formation of differential equation, where a family of curve is given and we will reduce it into a differential equation. Here there are two methods that we use. One is that of substitution, another one is that of elimination. Once we have done that, the order of differential equation is same as the number of effective constants. Now once we move towards the next part, we move towards solution and we look into two types of solution, general and particular solution. Further, the discussion move towards variable separable and we are going to look into four important types. One is variable separable, homogeneous, linear differential, exact. Then we go into subtypes of linear variable separable in terms of involving functions, linear functions of ax plus b, by plus c. Then linear by linear form, and we can also use polar coordinate form and one more form. Now we move discussion towards homogeneous, where we first deal into the direct idea of homogeneous, then two reducible forms like linear by linear and reducible form, and then linear differential equation in y, in x based on substitution, Bernoulli's equation, and then exact differential equation. Now after this we move our discussion towards some miscellaneous application in terms of geometrical problems and some more problems, and at the level of JEE advanced Clairaut's equation and trajectory. First one is formation of differential equation. Now if I look into formation of differential equation, there are two very important methods. A family of curve is given, either we are going to use elimination method or substitution method. The one that is more feasible will be used based on the question given. In the first method, we are going to single out the constant, differentiate, get rid of the constant. So the order will be equal to number of effective constants. In the second part, we are going to differentiate and then substitute towards the end to remove all the constants. These are the two prominent methods that are used to solve a question. Now if I look into this 2024 question says that differential equation of family of circles passing through origin and having center at y is equal to axis. Now if you look into this question, first we'll have to write the equation in coordinate geometry form, and hence basic knowledge of coordinate geometry becomes important in solving such questions. So family of circles passing through origin. So now if I write the general equation, it is x square plus y square plus 2gx plus 2fy plus c equal to 0. So if I am writing it like this, now if it passes through origin, then c will be equal to 0. And the second is having center at y is equal to x, then minus g will be equal to minus f, because the center is minus g comma minus f. So you can see that g comes out to be equal to f. This is the first part, wherein by applying this condition we were able to come up with the generalized equation x square plus y square plus 2gx plus 2gy is equal to 0. And as you can see that there is only one effective constant, so the order is also going to be 1. Now let us solve. So now what we can do is we can here either single out the constant, and I will show you both the methods using this question. So if I want to single out the constant, what I can do is I can put x square plus y square on one side. We can take minus 2g common and write it like this. So if you want to write the final equation, it will become x square plus y square, and this is method 1, by x plus y. And the constant term I have kept on the other side. We will try and eliminate this and get a differential equation. So now I can differentiate both the sides. So derivative with respect to x on both the sides. You can see that if I want to do the derivative on the left hand side, I will have to apply division rule. And if I do it so, let us see what do we get. So differentiation of numerator will become 2x plus 2y divided by dx into x plus y minus x square plus y square, and derivative of denominator, that will be 1 plus dy by dx. And the denominator will be squared, so x plus y whole square. And this is equal to 0. So if I simplify, what am I getting? And in this question, since they have written dx and dy on the both the sides, so let us simplify and write it down. So the first part becomes 2x into x plus y plus 2y into x plus y dy by dx. The remaining part becomes minus x square minus y square, or we can take minus common, and minus x square plus y square dy by dx is equal to 0, because denominator, if it goes on the right hand side, will become 0. Now if I simplify this, let us see what do we get. So we can write this as nothing but twice of x square plus 2xy. From that, 1x square will get cancelled out. So this will become x square plus 2xy minus y square, and whatever is with dy by dx, now this will become 2xy plus y square, and if I again subtract, so what am I going to get is 2xy plus y square minus x square dy by dx is equal to 0. Now if I want to split it in dy by dx, let us take one on the left hand side, another one on the right hand side. Based on the pattern given in the question, dy is on the other side. So this can be written as, in turn, x square plus 2xy minus y square into dx is equal to x square minus 2xy minus y square dy. If I check the option, you can clearly see that my D option matches. Now in method 2, we are going to apply substitution in order to solve this question. So we will differentiate both the sides. So twice of x, twice of y, dy by dx can easily be written. Here we are going to get minus 2g 1 plus dy by dx. Now from here, what we can do is, from the first part, you can substitute the value of minus 2g in this. So we have already 2x plus 2y dy by dx. In this, we are going to substitute the value from the first part. So it will become x square plus y square by x plus y into 1 plus dy by dx. If we do this, we can cross multiply and simplify. If I cross multiply, this becomes 2x square plus 2xy. The second part becomes 2xy plus 2y square dy by dx. And this becomes x square plus y square plus x square plus y square dy by dx. If I simplify this, you can see that you can take the left hand, this term on the left hand side. So it will become x square minus y square plus 2xy, and the right hand side terms becomes nothing but x square plus, so this plus y square will be replaced by minus y square minus 2xy into dy by dx. Dx also can be taken on this side. If I write it like this, you can see that again D option matches. So this second method is substitution, first one was elimination. If I look into this next 2024 question, this question says that if I find area, and area we have already done, area under curve from 0 to a, fx dx, the answer for that comes out to be e raised to the power minus a plus 4a square plus a minus 1. This is the first information that they have given to us. Second, what they are saying is nothing but if they want us to find the differential equation of this curve. Y is equal to c1 fx plus c2, and here we are going to use substitution method. So if I differentiate it, this becomes dy by dx is equal to c1 f dash of x. And now, since there are two effective constants, we'll have to differentiate two times. So if I differentiate it one more time, d2y by d2x square will be equal to c1 f double dash of x. And if I now substitute the value of c1 from the first part, you can see that c1 is nothing but dy by dx divided by f dash of x. So if I write this up, this becomes f double dash x by f dash of x into dy by dx. This is what we are writing. Now once we have written it down like this, it boils down to getting the value of f double dash of x and f dash of x. Now for that we have been given an area based equation. So if I differentiate with respect to a, so what I am doing is I am differentiating with respect to a on both the sides. So if I use my Newton-Leibniz formula for doing that, what will I get on the left hand side is f of a, and then this will be equal to minus e raised to the power minus a plus 8a plus 1. And now here you can replace a by x, and if I do it so, it is e raised to the power minus x plus 8x plus 1. Now this is not what we want. What we want is the derivative. So if I differentiate this once, it becomes nothing but e raised to the power minus x plus 8. And if I differentiate it one more time, it is minus e raised to the power minus x. Now if I find their ratio, f dash of x by f dash of x, f double dash of x by f dash of x, this will be equal to nothing but minus e raised to the power minus x by e raised to the power minus x plus 8, and that in turn comes out to be minus 1 by 1 plus 8 e raised to the power x. Once we have got this, now we can substitute this in the d2y by dx equation that we have got. So d2y by dx square will become nothing but minus 1 by 1 plus 8 e raised to the power x dy by dx. Now if I simplify this, I will get my answer. So if simplified, this turns into 1 plus 8 e raised to the power x d2y by dx square plus dy by dx is equal to 0. And if I check the options, you can see that B option matches. Now the next important discussion is solving differential equation. Now if I solve differential equation, what does that mean? It means finding a relationship between dependent and independent variable, that is y and x, satisfying differential equation free from derivatives. We need to remove the derivative part. This is what a solution means. Now there are two types of solution: general solution, particular solution. General solution would mean we'll get a c or a constant term in the answer. If you can figure out the value of c, in some particular cases you will get a particular solution. Now we are going to solve largely these four types of differential equation in this chapter. First is variable separable, homogeneous, linear and exact, and then each of these will have some reducible forms. Now let us start with the first one, or in the type 2 problem, that is variable separable form. What is the algorithm for solving such questions? We will separate variables. So on one side there will be x terms and on the other side there will be y terms, and then we'll integrate to get the answer. So these are the two steps that we are going to use in order to solve this question, let me show you using an example. So this is the process that I have shown you. And now once we have applied this process, let us see this question that came in 2024. The question clearly says that you have been given, so if I separate the variables, so 2y minus 5 dy by dx would be equal to minus 3. You can see that now by doing this we have separated the variables. So dy can be written here, and then in the remaining term will become minus 3 dx. You can see that the variables are separated. In the next step we are going to integrate and get the answer. So if I integrate, this becomes 2y minus 5 dy. This is integration minus 3 dx. And if I write it down, this becomes y square minus 5y. This will become minus 3x. Let's see. This is what we are getting as an answer. Now the question says that the solution curve for the differential equation passing through the point 0, 1. So passing through 0, 1 would mean they are asking a particular solution. So let us figure out the value of c by substituting 0 and 1. So this will become 1. And this x will become nothing but 0. So what we have is nothing but c. The value of c comes out to be minus 4. Another important information. Now we can see that in the fourth part it becomes some other question of conics that they are trying to add up here. So we have already got our equation y square minus 5y is equal to minus 3x minus 4. What they have added is, this is a conic whose vertex lies on the line. So first you will have to find the vertex, and for that you will have to generate a perfect square. So y minus 5 by 2 whole square minus 25 by 4. This will be equal to minus 3x minus 4. And if I take everything on the right hand side, let us see what do we get. So y minus 5 by 2 whole square will be equal to minus 3x minus 4 plus 25 by 4. If I simplify this, it comes out to be nothing but minus 3x plus 9 by 4. And if I take minus 3 common, this becomes x minus 3 by 4. So now if I look into the vertex in the fifth step, the vertex comes out to be 3 by 4 comma 5 by 2. 3 by 4 is coming from this part and 5 by 2 is coming from this part. Now option says that what is the value of 2x plus 3y. So let us do 2x plus 3y. So if I put 3 by 4, this will become 3 by 2. And if I put 5 by 2, this will become 15 by 2. It will add up to 18 by 2. That is nothing but 9. So let us see that. You can see that the C option comes out to be the correct. If I look into this next 2024 question, this question is based on variable separable very clearly, because you can see that I can in one line separate the variables. So I can write all of this term on the left hand side, and we can take 2x square plus 2x plus 3 dx on the right hand side. Now the variable separable part is very simple. All we need to do is take this term that is on the right hand side and move it on the left hand side to right hand side. And you can see that the terms are already separated. And in the next part, what we can do is we can apply by parts. We can apply integration. If I integrate, it seems like we were able to do the question. But the actual catch of this question and all such variable separable question would be in integration. So your ability to handle this question would be as good as handling integration. So now we can see that we have written everything up. Now the question is how to integrate this, and in order to integrate, now we'll have to understand that there in integration there are only 4 techniques. Either I can split a term, or I can do some substitution, or I can apply by parts, or I can apply partial fraction. Now in this question, now in every integration question, something out of this 4 you need to do. Now here also we have this idea that whenever you have composite function, we do substitution. Whenever you have multiplication of two functions, we generally apply by parts, and whenever there is division of two functions, we apply partial fraction. So we should think in the direction of splitting the denominator and apply partial fraction. So now if I write the denominator, it is possible to factorize it. So what we need to do is we need to choose and split it into right kind of terms. So what we can do is we can take x raised to the power 4 from here, 1x square term from here. We can take this x cube and x term. So 2x cube plus 2x. And then we can take a 2x square plus 2, these two terms. So once we do that, we can take x square common. So this becomes x square plus 1. We can take 2x common. Again it becomes x square plus 1. And again we can take 2 common. So again you can see that x square plus 1 comes out as common. So the question becomes x square plus 1 into x square plus 2x plus 2. Now the interesting part is the question is built in this manner that in the numerator you can see this term is nothing but the sum of x square plus 1 and x square plus 2x. So now we can split it off very easily into two terms or two integrals that can be integrated. So numerator can be written as x square plus 2x plus 2 plus x square plus 1 divided by x square plus 2x plus 2. That is the denominator that we have just factorized. And now you can see that very easily I can split into two integrals after doing the partial fractions part or splitting it into two parts. So once we have done that, you can see that this comes out to be x square plus 2x plus 2 in the denominator. And now I can integrate in the third step. So in the third step, if I integrate this, it becomes dx by x square plus 1 and integral of dx by, even I can write this as a perfect square. So x plus 1 whole square plus 1, and which eventually will be integrated into tan inverse x plus tan inverse x plus 1 plus c. Now let us read the question further. So now the question says that once you have done that, this is satisfied by minus 1 comma minus pi by 4. So now in this question, in this fourth part, if I put x as minus 1, y comes out to be minus pi by 4. So if I put minus 1, my left hand side will become minus pi by 4. Right hand side becomes tan inverse of minus 1 minus pi by 4 plus 0 plus c. This cancels out and the value of c becomes 0. Then in the fifth part, they want us to find the value of the function when we put x equal to 0. So in the fifth part, let us find y at x equal to 0. If I put 0, the first part becomes 0. Second will become tan inverse 1. And the constant term is also 0. The answer becomes pi. Now let us check the options. You can see that option D matches. If I look into this 2024 question, it uses the similar kind of idea. So if I just write this expression that is given to me in terms of y, it will be much easier on the eyes. I can write this as nothing but dy by dx is equal to alpha y plus 3. Now see, it is very easy to see that it is a variable separable. We can write it as dy by alpha y plus 3 is equal to dx. And in the next step, as the algorithm goes, we are going to integrate it. So this is what we are getting. Now if I integrate, the integration is very simple. This will become alpha y plus 3 log of this divided by alpha. This will become x plus c. So if I want to find the value of, now let us find the value of c first and then do something else. So in the third part, Let us figure out the value of c, and for that they have given the value of function is 2 at 0. So y is equal to 2 when you put x is equal to 0. If I put these values, this will become ln of 2 alpha plus 3 modulus of this divided by alpha is equal to c. Once you've got the value of c, let us substitute it back in the fourth step. It is going to become ln alpha y plus 3 mod of this by alpha is equal to x plus ln of 2 alpha plus 3 mod of this by alpha. If I take it on the left hand side, ln of alpha y plus 3 modulus minus ln of 2 alpha plus 3 modulus by alpha will come. And once I simplify this also, it becomes ln of alpha y plus 3 by 2 alpha plus 3 modulus of this is equal to alpha x. This can be in turn simplified and written as alpha y plus 3 by 2 alpha plus 3 is equal to e raised to the power alpha x. And now if you want to simplify further, let us figure out the value of alpha using the next relation. What they have given is, if I put x tends to infinity, now what is going to be the value? So now if I put limit on both the side, limit of x tends to minus infinity, limit x tends to minus infinity. So this is alpha and this is infinity, it's slightly different. So once you put this limit, we know that at minus infinity, this is going to become 0. And this is also given that the value of alpha corresponding to this becomes 1. So numerator will become alpha plus 3. Numerator becomes 2 alpha plus 3. So if I solve it from here, value of alpha comes out to be minus 3. So what we have done is, we have also figured out the value of alpha in the step 4. Then in the step 5, let us see what they are asking. They are asking the value of minus ln 2, but before that, let us simplify the function. So if I simplify the function now, how does it look? In the fifth step, if I put the value alpha y is fine, and also we have got the value of alpha, it is nothing but minus 3. So this becomes minus 3y plus 3 divided by minus 3 into 2 will become minus 6. This becomes minus 3. Minus 3x. Now if I substitute the value here, let us see what we are getting. If I simplify, this expression becomes nothing but, if I can remove this 3, so y minus 1 is equal to e raised to the power minus 3x, or y is equal to e raised to the power minus 3x plus 1. We have got this value, and now we want the value of minus ln 2 at minus ln 2. So if I put minus ln 2 here, let us see what do we get. So my answer comes out to be, in the sixth step, y is equal to e raised to the power 3 ln 2 plus 1. And this becomes ln of 2 raised to the power 3 plus 1. And this will become 8 plus 1. Answer comes out to be 9. And now if I check the option, you can see that B option comes out to be correct. If I look into this 2020 question, and it feels like the terms are mixed up, but it can be separated if you do a very small thing here. So what we can do here is, I can factorize the first part as nothing but root of 1 plus x square into 1 plus y square. Rest of the terms I can take on the other side. And now you can see that the variables are getting separated. We can write this as dx into minus x root of 1 plus x square. On the other side, you have minus dy by root of 1 plus y square. Now, both of these can be integrated very simply. So I have given you a hint, you can try this, and the answer to this question comes out to be option A. Now again, this 2020 question, it looks a little bit weird, but you can reorder terms so that a variable separable question appears out of it. So we can write x cube dy minus x square dy is equal to 2y dx minus xy dx. Once I write it like this becomes x cube minus x square dy. And this will become 2 minus x into y dx. If I simplify this, you can see that this comes out to be dy by y is equal to 2 minus x by x cube minus x square dx. So again, we can see that in the next step, it can be integrated and we can get the answer. So this is again a question based on variable separation. So again, I have dropped a hint for you. You can continue after this. Now this 2019 question is extremely interesting because you need to observe few things. They have given a relationship between x and y. If you have f of x into y, the value of that is equal to f of x into f of y. Now this is not a generic functional equation because in that case we can write the answer as x raised to the power n plus 1 or x raised to the power n, whatever you want to write. This is how we solve it. But here there is something different, it is happening. So now what they are saying is f of 0 is not equal to 0. So if I put the value of y as 0 and the value of x is 1, let us see, or x is x, we can keep the x's. Then what will happen? This will become 0. This will remain x and this will become 0. If I factorize this, f of x into f of 0 minus f of 0 will be equal to 0. So f of x minus 1 into f of 0 will be equal to 0. So there are two possibilities here. One, either f of 0 becomes equal to 0 or f of x minus 1 equal to 0, which eventually result into f of x being 1. Question says that this is not possible. It has been written that f of 0 is not equal to 0. So this is not possible. This is the only case, and this makes question extremely easy because now there is next part of the question, another function yx. So for this yx, now we know that dy by dx is equal to 1 because fx came out to be 1. From here, if I separate the variables, it would be very simple. We will get y is equal to x plus c. In order to find the value of c, the value of y of 0 is given. So this is 1, c comes out to be 1. So the function from here is y is equal to x plus 1. Once we have got this function, the next part is extremely simple. In the third part, we can just substitute the value of y 1 by 4. This will become 1 by 4 plus 1 and y 3 by 4. That will become 3 by 4 plus 1. We can add them and get the answer. The answer comes out to be nothing but 3. That is nothing but option B. Now in type 3, there are equations reducible to variable separable form. Now we can see that in this derivative will be equal to some linear function of x and y. Now once you have this, in 2024 question, what is the standard way of solving this? Whatever is this function, linear function, in generic way we should put ax plus by plus c equal to t. And after this substitution, it will become a variable separable. These are the two steps that we need to take. So in this 2024 question, the first step would be to put x plus y as t. So 1 plus dy by dx is equal to dt by dx. Now we will do two substitutions. One is the value of dy by dx, we will substitute here. So this comes out to be dt by dx minus 1. And then we can substitute here. So if I substitute here, this becomes 2x t cube minus xt minus 1. Minus 1 gets cancelled out. And now you can see that clearly it is a variable separable. dt by dx is fine. I can write this part as nothing but x can be taken common, 2 t cube minus t. And if I write it like this, now you can see that this can be written as dt by 2 t cube minus t is equal to x t x. Now in the next part, if I want to integrate this in the third part, let us integrate. So this becomes dt by 2t cube minus t is equal to x dx. Now this, in order to integrate the first part, and we did this also, we can take t cube common. So this will become t raised to the power minus 3 dt. This is 2 minus t raised to the power minus 2. And this becomes x square by 2 plus. Now you can see that whatever is written here, the derivative is written in numerator. So 2 minus t raised to the power minus 2 can be put as e. And the derivative becomes plus 2 t raised to the power minus 3 dt is equal to t. So if I put the value here, let us see what is the answer that we are getting. So 1 by 2 times, and now you can see that this will become du, this will become u. We have x square by 2 plus c. So as a result, what we get is ln of mod of u divided by 2 is equal to x square by 2 plus c. 2 we can cancel out, it will go here. But see, in constant writing one more constant does not make sense. Or if you are not comfortable with this, then you can also write it as x square plus some new constant c dash. This is what we are getting. Now let us resubstitute all the old bits. So first one was the value of u. So u if I put. So in fact, what we will do is we will directly, it is fine, we will put the value of u. So 2 minus t raised to the power minus 2 mod of this is equal to x square plus c dash. And now we will also put the value of t here, that is x plus y. And this is the answer that we are getting. Now once you have got this answer, now let us go and figure out the value of the expression they are asking us to find. But for that they have given the value of at x equal to 0, y is equal to 1. This curve passes. In the fourth step, we can just write it like this. This curve passes through 0, 1. If I put x equal to 0, y becomes 1. So if I put this value, this is 2 minus 0 and 1. This will become 1. This becomes 0 and this becomes c dash. The value of c dash from here comes out to be 0. Now in the fifth part, we have got the value of 2 minus x plus y raised to the power minus 2. This is nothing but e raised to the power x square. And now once you have got this value, we can just figure out by putting 1 by root 2, y 1 by root 2. So this fundamentally means that we need to figure out the value when x is equal to 1 by root 2. And then corresponding to that, whatever y comes to, what we want is the value of this part. Now fundamentally speaking, now when they write this square of this, so let us simplify and write it in the better form and then do the deed. This will be equal to 2 minus e raised to the power x square, and x plus y raised to the power 2 is 1 upon 2 minus e raised to the power x square. You can see that what I need to do is just put the value of x is equal to 1 by root 2 in this and get the answer. So it becomes 1 upon 2 minus e raised to the power 1 by 2. So it is nothing but 2 minus root 2 in the denominator, and you can see that D option matches. Now for solving this 2024 question says that you have been given equation in the same reducible form that we and then there is a tail to a question now. You are saying the maximum and minimum value of this function in 0, pi by 3 is alpha, beta, and they want us to find the value of this expression. So once we have looked into this question, now let us see what we can do. So you can see that since it is reducible to variable separable, we will put x plus y plus 2 is equal to t. And once you do this, this is 1 plus dy by dx is equal to dt by dx. In the second part, we are going to substitute value. So this becomes t square is equal to dy by dx, and that is nothing but dt by dx minus 1. Once you have got this value, the value of dt by dx is nothing but 1 plus t square. Variable can be separated and integration would be done to get the answer. And once you do it, in the third step, you have got the answer as tan inverse t is equal to x plus c. Let us resubstitute the value of t as well. This was nothing but x plus y plus 2. Now, in order to find the value of constant, they have given the value of the function is minus 2 at 0. So this becomes tan inverse 0 minus 2 plus 2 is equal to 0 plus c. So you can see that c also comes out to be 0. So now the solution is wholesome. We have got the value of the function. In the fourth step, let us write it. So tan inverse x plus y plus 2 is equal to x. You can see that x plus y plus 2 is equal to tan x, and y is equal to tan x minus x minus 2. So now if I find the derivative of the function in the fifth step, it comes out to be sec square x minus 1. Now this can be used to figure out the maxima and minima in this duration. So if I put it equal to 0, you can see that this function sec square x minus 1, in fact you do not need to go and put it equal to 0. The minimum value of sec square x is going to be 1. So this is always going to be greater than or equal to 0. You can see that it is an increasing function, wherein the minimum value will come at 0 and then it will keep on increasing till pi by 3. And hence you can see that the value of alpha, that is nothing but the maximum value, will appear at pi by 3. So if I put pi by 3, it becomes root 3 minus pi by 3 minus 2. And if you put the value of beta, beta is nothing but the minimum value. The minimum value will come at 0. That is nothing but minus 2. So we have got the value of alpha and beta. Now they are saying that if you figure out 3 alpha plus pi, so the additional layer they are trying to add on the same question. So let us also do that. In the last part or the sixth part, let us figure out the value of 3 alpha plus pi. So 3 alpha plus pi would be equal to nothing but 3 root 3 minus 6. And they are also asking us to square and add it to beta square. So if I square this, this is what we get. And then we have got the value of beta. Beta is nothing but minus 2. And if I square it, this is going to become 4. Now what they are saying is add all of this and then you will get gamma and delta from there. So they are just trying to flip the same question in multiple ways. So this will become 9 into 3, 27 plus 36. Minus 6 into 3, 18. 18 into 2 will be 36 root 3. And then if I add beta square, this will become 4. So now in the next part, what they are saying is whatever is here is nothing but gamma. If you write the value of gamma, it is 27 plus 36 plus 4. So 40 plus 27 is nothing but 67. And this is my gamma. And my delta is nothing but minus 36. So once we have compared this and figure out the value of gamma and delta, what they want us to find is sum of both of these. If I do gamma plus delta, let us see what do I get. So gamma plus delta, if you do, this will add up and become 1. This will become 31. That is nothing but the answer to this question. Now type 4 question is based on homogeneous differential equation. A homogeneous differential equation is one in which if you add the powers of variable in every term, it comes out to be the same. Now how to solve it? So there is a 4-step process for solving this. First we will observe whether the powers are adding up or not. Then we will substitute y as tx. Based on that, it will reduce to a variable separable. Then after solving, resubstitute the value of y and get the answer. If I look into this question, again we are going to implement the same steps because we have observed that this is nothing but a homogeneous form. The powers of x and y will add up in every term 2, 2. Once you have observed that, the first step should be to divide by x square. And also divide by dx. So this will become 5 times y by x. dy by dx is equal to 0, and I can simplify and write it further as dy by dx is equal to 1 plus y by x whole square by 5 times y by x. Now why are we doing this? You will understand in a minute. So in step 2, we are going to substitute y as dx or y by x as t, same thing. So this will become dy by dx is equal to t plus x dt by dx. Now these steps are going to be standard and will come in every question. Now in the next step, third step, let us substitute all the values. So this becomes a t plus x dt by dx. The right hand side becomes 1 plus t square by 5 times t. Now we can take t on the other side. So x dt by dx is equal to 1 plus t square by 5t minus t. And this will simplify it to 1 minus 4t square by 5. Once we have got this, it has become a variable separable. So in the fourth part, let us do the variable separable part. So now on the left hand side we have x dt by dx, and on the right hand side we have 1 minus 4t square by 5t. I can rearrange the terms, can be written as 5t by 1 minus 4t square dt, and this can be written as nothing but dx by x. Now we can integrate both of these. So you can see that if I substitute the denominator as u, that is 1 minus 4t square, if I put it as u, it will become minus of 8t, and dt is equal to du. And as a result, this will become du. This is du. And as a result, you will get du in the numerator. 5 was already there. Minus 1 by 8 also came. And this becomes nothing but u. This becomes ln of mod of x plus c. If I integrate this, this becomes minus of 5 by 8 ln of mod of u, ln of mod of x plus c. And if you put this value, you can see that at x equal to 0, y, at x equal to 1, y is equal to 0. So let us first resubstitute all the values. So this will become 1 minus 4t square is equal to ln of mod of x plus c, and t, this is nothing but minus 5 by 8, 1 minus 4 y square by x square का modulus. Once we have done that, now what we can do is we can substitute the value and get the value of c. So now what I can do in the next step is, in the fifth step, I can put x equal to 0, y will be equal to 1, y will be x equal to 1, y will be equal to 0 corresponding to that. And if I do this, correspondingly the value of c will also come out to 0. So my question becomes, or reduces into ln of 1 minus 4y square by x square raised to the power minus 5 by 8 is equal to ln of mod of x. Or I can write this as 1 minus 4 y square by x square is equal to x raised to the power 5 by 8. If I solve this further, it is going to become 1 minus 4 y square by x square raised to the power minus 5 by 8. And this is going to become nothing but x. Now, if I simplify this, this will become x square minus 4y square raised to the power minus 5. We have x raised to the power minus 10 by 8. This we can take on the other side. And if I take it on the other side, this becomes x square minus 4y square raised to the power minus 5. This is going to become x raised to the power minus 2 by 8. This was 5 by 8. Now I can flip it and write it as x square minus 4y square raised to the power plus 5 by 8. This will become x raised to the power 2 by 8. And we can raise it to the power 8, and this 1 by 8 will go away. So this is the final answer that we are getting. If I check the options, you can see that the A option matches. Now in this 2024 question, they are trying to flip the idea a little bit by already giving the solution to the equation. They have also given us the differential equation. What they are asking is the value of alpha in this case, or alpha square in this case. First we'll solve the differential equation, get the value of alpha, and then give the answer. So let us first write or observe the differential equation. So what we have, x cos y by x dy by dx is equal to y cos y by x plus x. You can see that the power of variable in every term is 1. So now what I can do is I can simply divide it by x. So this x will go away. And everywhere we have y by x terms. In fact, we can simplify it further and write it as dy by dx is equal to y by x cos of y by x plus 1 by cos of y by x. If I can write like this, in the next step or the second step, I can put y by x is equal to t. Or in other words, y is equal to tx. Once you have done this, the standard steps will follow. Dy by dx is equal to t plus x dt by dx. And once we have done that, in the next step, we will substitute these things. So t plus x dt by dx. This will be equal to t cos t plus 1 by cos t. Now we can take t on the other hand side, simplify and then integrate. So if I take t cos t plus 1 minus t, so this becomes nothing but 1 by cos t. As a result, now you can see that a variable separable form has been generated. So if I do it in the fourth step, what am I going to do is, I am going to separate the variables. So I have this x dt by dx. So I can write this as cos of t dt is equal to dx by x and integrate both the sides. Integration of cos x is nothing but sin x, so sin t. On the right side we have ln of mod of x plus c. If I resubstitute the value, this becomes sine of y by x. This is my fifth step, is equal to ln of mod of x plus c. In order to find the value of c or the constant term, you can see that when they had also given us the solution, this is the same solution. Only thing is what we are writing here is c is nothing but alpha by 2 in that case. So what we can do is we can simply find the value of c, get the alpha by 2 from here, then alpha. If I want to get the value of c, and instead of doing that, we can directly replace this and write this as alpha by 2. Now for finding this, they have given the value of x equal to 1, y becomes pi by 3. So this will become sine of pi by 3. This will become 0 and this will become alpha by 2. So alpha is nothing but equal to root 3. Alpha square will become 3. So D option matches. Now type 5 questions are reducible to homogeneous form. Any question that looks like this, a linear expression by linear expression, can be reduced to a homogeneous differential equation. We will see some sub cases when the calculation will become easier in this case, and that will cover in other differential equations. Now in this question you can see that first we'll observe that it is linear by linear, and then we are going to do substitution of small x is equal to capital X plus h, small y is equal to capital Y plus k. This will reduce to a homogeneous. That again will be solved like we solve a homogeneous, put y is equal to tx. Solve it, resubstitute everything and get the final answer. So in this 2024 question, we have been given this form. So if you carefully observe, it is nothing but linear of x and y numerator and denominator. So first step would be to put small x as nothing but capital X plus h. H is a constant. And small y is nothing but capital Y plus k, and as a result you will see that if I write dy by dx, it will be equal to d of capital Y by d of capital X. It is not going to get affected. Now once you have done that, in the next part let us do this substitution. So d of capital Y by d of capital X in place of dy by dx. In place of small x, we can write capital X plus h, capital Y plus k minus 2, capital X plus h, capital Y plus k. And this, there is a minus sign in the denominator. Once you have done this, there is one more step to be taken care. So we can write this as capital X plus capital Y, h plus k minus 2, and denominator capital X minus capital Y plus h minus k. See, if I want to make it into homogeneous, these constant terms that I have written here should become 0. So in the next step, third step, I will write h plus k minus 2 is equal to 0 and h minus k is equal to 0. From here we are getting the value as h is equal to k. If I put it in this equation that is given to us, twice of h will be equal to 2. H comes out to be 1, and as a result at h and k, both of these constants are 1. So see, we did not know what to put as small x or small y, but we assumed it, and ultimately we followed through the question to get the value of h and k. This is a very important part. Now once you have done that, in the next step or the fourth step, what are we going to do? We are going to write this as d of capital Y by d of capital X. And this is going to become capital X plus Y by capital X minus Y. And now we can see that this is a homogeneous differential equation. This can in turn be written as 1 plus capital Y by capital X, 1 minus capital Y by capital X. And now we can put capital Y is equal to t times capital X. This will become d of capital Y by d of capital X is equal to t plus capital X dt by dx. So in the fifth part, if I substitute, let us see what do I get. This is t plus capital X dt by dx on the left hand side. On the right hand side, we will have 1 plus t by 1 minus t. If I simplify, x plus dt by dx will be equal to 1 plus t by 1 minus t minus t. And if I simplify this, the left hand side comes out to be, there will be t, so this is 1 plus t minus t square, so this will become 1 plus t square by 1 minus t. Now once I have this, the next step becomes very simple. We can separate the variables in the sixth part. So in the sixth part, let us separate the variables. This will become dt into 1 minus t by 1 plus t square. This will become d of capital X by x. Now once this variable separable, we can integrate it. So 1 minus t by 1 plus t square dt is equal to dx by x. And once you have done this integration, you can see that this can again be in turn split into two parts, gt by 1 plus t square, and this will become t dt by 1 plus t square, and this will become ln of mod of x plus c. So this becomes tan inverse t. This will become ln of 1 plus t square mod divided by 2. And this is ln of mod of x plus c. This is what we are getting. Once you have got this, now let us go back to the question. It says that the curve passes through a point 2, 1. This will help us find the constant term. So if I find the constant term, let us see what do I get. So point is 2, 1. So let us put the point. But before that, let us resubstitute everything. So in the next step, and this was my 7th step, I am resubstituting it. So this becomes tan inverse of capital Y by x and y. Y by x, capital Y by capital X minus ln 1 by 2 1 plus capital Y square by x square ln of mod of x plus c. We should also write it here. The value of y was nothing but small y plus h. If you remember, from here if I want to get the value, it will be small y minus k is 1. So this will become y minus 1 by x minus 1. Let us do a small simplification before doing this, because it will make our life easy. So tan inverse of y by capital X, and we can bring this ln here on this side. So this will become ln of 1 plus y square by x square. 1 by 2 is there. It will get multiplied and become x square is equal to c. And you can see that what we are getting ultimately is tan inverse of y by capital X minus 1 by 2 ln of x square plus y square is equal to c. Once we have this, now let us put the values. So tan inverse of y, capital Y will be equal to small y minus 1, small x minus 1. This will become 1 by 2 ln of small x minus 1 whole square, small y minus 1 whole square is equal to c. Now, in order to get the value of c, we will have to, this curve passes through a point 2, 1. So let us put 2, 1 into this. So this becomes a tan inverse of 2 minus 2, 1. So this will become 0. 2 comma 1 would mean this becomes 1. As a result, C also comes out to be 0. Now we have figured out the value of C. Our final expression now looks something like this. It looks as tan inverse of y minus 1 by x minus 1 minus 1 by 2 ln of x minus 1 whole square plus y minus 1 whole square equal to 0. This is how my final answer looks like. Let us now check the options. So tan inverse 5, it is already there. So if I compare the value of beta, this value of beta they have given in this manner. So I can bring this ln of mod of x on the left hand side. So you can see that here if you write and compare, beta will come out to be 2 and alpha will come out to be 1. Once you have got the value of alpha and beta, what they are asking is beta, 5 beta plus alpha. So beta is nothing but 2. So this will become 10. 5 beta plus alpha, alpha is 1. The answer comes out to be 11 for this question. Now this variation of similar problem came in 2022. So it looks like it is not a homogeneous equation if you just look into it. But if you carefully observe and do a substitution, so let us write it like x minus y square plus 5x plus y square y dy by dx is equal to 0. If I write it like this and then after just one step, even you would be able to see what is happening. So this will become y square minus x by y square plus 5x. So you can see that had there been a team in a y or a t that which would have one power in place of two powers, that is y square, it would have become a homogeneous one. So what we can do is we can put y square equal to t in the next step, and if I do it so, 2y dy by dx will be equal to dt by dx, and as a result what will happen is this equation now will become homogeneous equation, and now this becomes t minus x by t plus 5x. Now in order to solve this one, what you can do is we can simplify it in the third step. Write this as 1 by 2 dt by dx as nothing but t by x minus 1 by t by x plus 5. Let us also take this 2 on the other side. This is what we are getting. And now we can put t is equal to ux. That would mean dt by dx is equal to u plus x du by dx. If I substitute this, the numerator is going to become du u plus x du by dx is equal to 2 times u minus 1 by u plus 5. And if I want to solve it like we do in any homogeneous equation, we will take u on the other side and simplify things. So this is going to become 2u minus 2 minus u square minus 5u by u plus 5, which ultimately simplified it turns into du by dx would be equal to minus u square minus 3u minus 2 by u plus 5, or u plus 5 by minus u square minus u minus 2 du is equal to dx. Now we can integrate both the sides and get the answer. So if I integrate this, I will have to use little bit of partial fraction. So let us take this minus sign out first. And now the denominator can be expressed as u plus 1 into u plus 2. Let us also write that. If I want to integrate this, I am integrating it separately here. So in the fourth part of the question, let us write the integration. So u plus 5 by u plus 1 into u plus 2. This can be written as partial fraction, that is 1 by u plus 1 if I write. This is a shortcut I told you. Put u plus 1 equal to 0, you will get u equal to minus 1. Put it in the remaining terms. So this will become 4, this will become 1. And then if I want to split the second part, if I am writing 1 by u plus 2, I will put u plus 2 equal to 0 and substitute in the remaining part. The numerator becomes 3 and the denominator becomes minus. So in the next part, if I want to integrate it, let us see what do we get. The integration of u plus 5 by u plus 1 into u plus 2 du will be equal to 4 times integration of 1 plus u plus 1 du minus 3 integration of du by u plus 2, and which eventually turns into, and I can write directly in the fifth part as nothing but minus was there, so that's my minus I'm absorbing, 4 ln u plus 1 modulus and plus 3 times ln u plus 2 modulus is equal to x plus c. This is what we are getting. Once we have got this, and let me check once more my calculation. There was an x here and I forgot to write the x, and this x will go on the other side, and this will also become ln of x. Once we have got this, now let us see, is there something else given in the question? Nothing else is given, so we can write the answer now. So you can see that we substituted here as nothing but t by x, and t was nothing but x, so u becomes y square by x. So let us substitute here. This will become y square by x plus 1, and this will become ln of y square by x plus 2, and last part is nothing but ln of mod of x plus c. Now let us check the options. So in options you can see that there is no ln term involved, so we'll have to eliminate this log term in order to get to an answer. So if I want to do that, let us write this. So this will become y square by x plus 1 raised to the power minus 4 into y square by x plus 2 raised to the power 3. This will be equal to x into a. And now let me write this right hand part in a little bit more detail. So log will come here, and on the other side it can be written as log of mod of x, and this plus c, I'm writing this into a. This kind of a situation will get developed. Now if I want to simplify, this will become y square plus x raised to the power minus 4 by x raised to the power minus 4, y square plus 2x raised to the power 3, x raised to the power 3 is equal to x into a. Now we can see that if I cross multiply all the things, these three things will get cancelled out, and what we will be able to get is y square plus 2x whole cube. This will be equal to y square plus x raised to the power plus 4. Now let us check the option. So you can clearly see that my A option matches. Now type 6 problems are based on linear differential equation. What is a linear differential equation? The one in which you have dy by dx, and then whatever is here, y, it should have a 1 power in this. P and Q here are nothing but functions of x. So this is very important to notice, because until unless you notice the right kind of equation, right kind of solution is not possible. Now this is the method to solve a linear differential equation. First observe that it is a linear differential equation. Find the integrating factor, and then the solution is y into integrating factor is equal to integration of q, that was the term on the right hand side, into integrating factor, and you integrate this. This is the method. Now if I look into this 2020 question, it is directly based on the idea that you have been given a solution and the differential equation. They want you to find the value of px. So what we just need to do in this question is, we just need to differentiate it. If I differentiate this one, it will become 2 by pi cosec x, and then so what I am doing is I am applying product rule. 2 by pi x minus 1 Derivative of cosec x would be nothing but minus cosec x cot x. So minus sign will come, cosec x will come, cot x will come. So once we have got this, now if you carefully observe, your y part was nothing but this part that is already written here. We can resubstitute this as y. So this can be written as dy by dx. 2 by pi cosec x minus y cot x. We can bring it on the left hand side. So dy by dx plus y cot x is equal to 2 by pi cosec x. And now if I compare this with this equation that is given to me in the second part, you will observe that px is equal to nothing but cot x. From these options, you can see that B option comes out to be correct. If I look into this next 2024 question, they have just jumbled up things up. So if we have fx is as nothing but y, f dash of x can be written as nothing but dy by dx. This is the first step. In the next one, if I substitute the value, this will become y sine 2x plus sine x minus 1 plus cos square x dy by dx will be equal to 0. Or we can write the value of dy by dx as nothing but y sine 2x by 1 plus cos square x plus sine x by 1 plus cos square x. Now, why are we writing it like this? We first want to write it in the standard form. So, what is the standard form? It is dy by dx. And then whatever is written here, I will bring this term on the left hand side, will become minus sine 2x by 1 plus cos square x into y. Now, whatever is on the other side will become q, that is sine x by 1 plus cos square x. Now, once we have this, in the third part, we can find the integrating factor. It is e raised to the power p dx. So, this part needs to be integrated. Now, what is the specialty about this part? Whatever is written in the denominator, that is 1 plus cos square x, its derivative, that is minus 2 sin x cos x, that is minus sin 2x dx, is given in the numerator. So, we will be very easily able to write this integrating factor as ln of 1 plus cos square x. That in turn becomes 1 plus cos square. Now, in the fourth part, let us write the final solution. Final solution is integrating factor into y is integration of integrating factor into q dx. So, this comes out to be nothing but 1 plus cos square x into y. And what we had on the other side is nothing but sin x. So, this is 1 plus cos square x into sin x by 1 plus cos square. So, this will get cancelled out, and what we are getting is minus of cos x plus c. This is 1 plus cos square x into y. We have figured out the solution of the differential equation. Now, what does it say is the value at 0 is 0. So, if I put x equal to 0, y will also become 0. Let us see what happens if I do so. The left hand side will become 0. Left hand side, right hand side will become 1. So, the value of c comes out to be 1. Now, again, if I write down the question and figure out the value in the last part, that is nothing but the fifth part. What I have is nothing but 1 plus cos square x into y is equal to minus cos x plus 1. And now they want to find the value of pi by 2. So, if I put x equal to pi by 2, let us see what happens. The left hand side will become y. The right hand side will become 1. So, y comes out to be 1. That is nothing but option. Now, let us follow the same process one more time so that we are able to develop clarity. Clearly, they have given us linear differential equation in y. We can first write the integrating factor. That in this case will become integration of 2x by 1 plus x square whole square dx. Now, when you want to integrate this, clear thing to be observed is 1 plus x square can be written as t. So 2x dx will be equal to dt. So this term that is in the power can be written as dt by t square. As a result, it becomes e raised to the power minus 1 by t, or minus 1 by 1 plus x square. We were able to find the integrating factor. Next steps are very simple. Second, let us write the solution. So y into e raised to the power minus 1 upon 1 plus x square. And now if I take this as q, not this as q, and if I multiply it, this is going to become x into e raised to the power 1 upon 1 plus x square. Integrating factor is minus 1 plus e raised to the power minus 1 upon 1 plus x square dx. So this will get cancelled out. Integration becomes x square by 2 plus c. So this is what our solution of differential equation looks like. Now what they're saying is the value at 0 is equal to 0. This will help us figure out the value of the constant. So if I put x equal to 0, y is 0, so left hand side becomes 0, this becomes 0. So c comes out to be 0. So the value of y here comes out to be x square by 2 e raised to the power 1 by 1 plus x square. So this is what my curve looks like. What they're saying is, if I write a curve fx, this is the third part. So we have solved the differential equation, that part is done. If I move toward the area enclosed, that is the second part of this question, they are saying that what is the area enclosed between fx and the line that they have given to us. So let us first write fx. If I write fx, the yx part that I have, if I put it here, you can see that this second part from here and here will get cancelled out, and what we will get is nothing but x square by 2. And the equation of line is nothing but y is equal to x plus 4. Now we need to find the area enclosed. For area enclosed, there are 3 to 4 steps that we usually follow. The first one is to draw the graph. And if I draw the graph, x square by 2 would be like this. Y is equal to x plus 4 will be a line that goes like this. If I want, the first step should be to find the point of intersections. If I substitute the value of y, x square by 2 should be equal to x plus 4. So x square minus 2x minus 8 will be equal to 0. This can be written as x minus 4 into x plus 2 equal. So this point becomes minus 2 and this point becomes nothing but 4. Once we have this much of information, now you can take a small element at a distance x dx and integrate this. So the integration part comes out to be minus 2 to 4. y2 minus y1, y is nothing but for that of the line, so that will become x plus 4. And from this I will subtract my curve, that is x square by 2, and get the answer. So my final answer comes out to be x square by 2 plus 4x minus x cube by 6 from minus 2 to 4. So if I put 4 here, let us see what do we get. So this will become 16 by 2, 8. This will become 16. And this will become 64 by 6. On the other hand, if I put minus 2, this becomes 4 by 2. This becomes 2. Minus 8 and plus 8 by 6. Now if I simplify this first part becomes nothing but 24. This will become minus 6 with minus n will become plus 6. So this comes out to be 30. 64 if you add, because there is a minus sign, minus 8 will get added up, will become 72. Divide by 6 will become 12. So answer becomes 18 square units. If I look into this 2022 question, it is again based on the idea of linear differential equation. But if you look into this equation, you can clearly make out that the value of px will be nothing but 2x square plus 11x plus 13 divided by x cube plus 6x square plus 11x plus 6. So in order to find integrating factor, that is our first step in all such questions, I will have to do integration of p dx. Now if you want to integrate this number, it is division of two polynomials, and hence the technique is very clear. We will have to use partial fraction. Whenever we are dividing a polynomial with polynomial, in those 70 to 80% cases we use this technique. So in order to apply partial fraction and find the integration of p dx, what we can do is we can write this as nothing but we need to factorize this denominator. So this is nothing but integration of 2x square plus 11x plus 13 by x cube plus 6x square plus 11x plus 6 dx. If you look into the denominator, x cube plus 6x square plus 11x plus 6, this can be written as x plus 1 into x plus 2 plus x plus 3. So it can be factorized like this, and hence we can write this as a partial fraction of 1 upon x plus 1. Now I have already told you when we are doing this in the rest of the part. So if I have written it like this, the numerator is going to be 2x square plus 11x plus 30 by x plus 1 into x plus 2 into x plus 3 dx. So in the remaining part, if I am looking for partial fraction of this part, then in the remaining part I will put x equal to minus 1. And if I do it, I will get the coefficient here. If I put minus 1, it is 2 minus 11 plus 13. So 2 minus 11 plus 13 and divide by 1 into 2 will come. So this is a shortcut that I taught in indefinite integrals when we did partial fractions there. I am using the shortcut here. If you don't know the shortcut, you can use the long cut method and do from there as well. There is no problem in doing so. But if you apply the shortcut, it becomes extremely fast. We can write this integral. This will become 4 by 2. That comes out to be 2. So we can write here 2 dx. The next one, when you do, now we will apply the similar technique, but since we are writing integration of 1 by x plus 2, in this case I will put minus 2. So if I put minus 2, this is 2 into 4 minus 22 plus 13. This becomes minus 1. This will become 1. So now we are putting value here, here and here. And if I do it so, this becomes 8 plus 13. 8 plus 13 will be equal to 21. So this will become 1. Minus 1 by minus 1, this becomes 1. And the last term would be nothing but integration of x 1 upon x plus 3. Now in this last one, again we'll put the value of x equal to minus 3 in the top term. So if I put there, this is 2 into 9 minus 33 plus 13 and divide by, the denominator will now become minus 2 into minus 1. So this we are doing, and if I simplify, this becomes 18 plus 33, 18 plus 33, 18 plus 13, so this will become minus 2, because this will become minus 20 and then 18, so minus 2 divided by minus 2. So answer becomes minus. All we need to do is put minus 1 here. You can see that the integration has become extremely simple. And now we will integrate and find the value of integrating factor and hence the answer. So if I do it, it is 2 ln of x plus 1 plus ln of x plus 2 mod ln of x plus 3 mod. This is what we are getting. And if I simplify, this will be equal to ln of x plus 1 whole square into x plus 2 by x plus 3. So if I want to find the integrating factor in this part, it will be e raised to the power all of these, or we can write it as x plus 1 whole square into x plus 2 by x plus 3. Now in the next part, second part, let us write the solution. So integrating factor into y is nothing but integrating factor into q, that in this case is x plus 3 by x plus 1. If I write integrating factor on the left hand side, this becomes x plus 1 whole square into x plus 2 by x plus 3 into y, and on the right hand side, if I do, you can see that x plus 3 and x plus 1 will get cancelled out. So 1 x plus 1 will remain and x plus 2 will remain. So once I simplify this, you can see that I can write this as x square plus 3x plus 2 dx, which in turn will become x cube by 3 3x square by 2, 2x plus c. Once you have got this, in the next step, we know that this curve passes through 0, 1. So if I take this, and in this, if I put 0, 1, I will get the value of c. So x equal to 0 if you put. The left hand side becomes 1 into 2 by 3 into y, which is nothing but 1. Now on the right hand side, this becomes c. The value of c is nothing but 2 by 3. Once you have got the value of c, the next part is find the value at 1. So if I put 1, the left hand side will become 2 square, that is 4 into 3 by 4 into y. And on the right hand side, if I put 1, this is going to become 1 by 3, 3 by 2, 2 plus 2 by 3, which if simplified, this will get cancelled out. And this is 3y is equal to 2 by 3 plus 1 by 3 will become 1 plus 2 plus 3 by 2. So this is nothing but 3 plus 3 by 2. That will be nothing but 9 by 2. So y comes out to be 3 by 2. Now let us check the options. The B option comes out to be the correct answer. Now we can see that in all such questions, the prime complexity that we are facing is with integration. So if you have mastered the indefinite and definite part, you should not face any problem in doing any question of linear differential equation. And you can see that if you look into the note that I will upload for this differential equation part, you will see lots and lots of simple questions were based on linear differential equation. The next problem type is type 7 linear differential equation in x. So when we write linear differential equation in x, instead of y, we will write x. So we will write dx by dy. Here there will be a function of y into x, then q function of y. So if something of this type is given, this is the function of y. So even if I write p, it is fine. If I write q, it is fine. So it is the same, only difference is instead of x there is y, instead of y there is x. So if you go and write the integrating factor in this one, it is going to become e raised to the power p dy. So this is something new. So if I look into this 2024 question, it is a linear differential equation in x, and that will mean that if you have written it like this, I can write it as dx by dy is equal to x by y plus 1 minus y square by y. And now you can see that just in a step, we can get a linear differential equation in x. So instead of y, x is there in the linear form. And see, here it is very simple. They have written it in such a manner that everything is very obvious. But sometimes the things will be jumbled and you will have to figure out whether x has a power 1 or y has a power 1. If y has a power 1 in all the expression, it will become linear differential equation in y. If x has a power 1, it will become linear differential equation in x. So now this is the first part. We have recognized it. In the second part, we can integrate it and find the integrating factor, which in this case will become integration of minus 1 by y dy, which will become e raised to the power minus ln y, which can be written as e raised to the power ln 1 by y. The answer becomes 1 by y. In the third part, now what we can do is we can write integrating factor into x is equal to q. Now q here is nothing but 1 minus y square by y into integrating factor. So if I write it like this, this is x by y. This will become 1 minus y square by y. If I solve this, it is not a very tough equation to solve, integral to solve. So 1 by y square dy minus dy, which will become minus 1 by y minus y plus c. So this is what we are getting. Now in order to find the value of c, what they have given is they have given, if I put x, y is 1, x will become 1. So if I put that value in the step 4, this will become 1, 1, this is c. So you can see that from here c comes out to be 3. Once we have figured that out, what they are asking is what is the value of 5 into x when we put value of y as 2. So this will become 2, this will become 2, this will become 2, and this is already 3. If I simplify, this comes out to be 1 minus 1 by 2, this will become 1 by 2. Value of x becomes 1. And now they are asking 5x. If I multiply by 5, it will become 5. So answer of this question is nothing but 5. If I look into this 2020 question, it is not that easy to figure out that it is linear differential equation in x. So you can see that multiple terms are given. It is not as simply presented as the last 2024 question. So what you will have to do, you will have to write it down a little bit. So we can rewrite it as dx by dy is equal to tan inverse y by 1 plus y square minus x by 1 plus y square. And now we can rearrange in the first step and write it so that it starts looking like a linear differential equation in x. So plus x by 1 plus y square. Now it looks proper. Once you have written it in this form, in the second part we'll find integrating factor. That becomes e raised to the power integration of 1 plus y square dy. And then this can be written as e raised to the power tan inverse x, tan inverse y. Once you have written it like this, now let us do the next part. Now in the next part, if you look in the third, we will have to write the integration. So integrating factor into x. So e raised to the power tan inverse y into x will be equal to integrating factor of this into tan inverse y by 1 plus y square dy. Now see, integration is not very tough in this question because all we need to do in order to integrate is put tan inverse y as t. As a result, dy by 1 plus y square will be equal to dt. And as a result, this will become e. Here also let us put t. And here also, if you want, you can keep things normal on the left hand side. In fact, let us keep here tan inverse y only. And here we can write it as nothing but e raised to the power t into t dt. And now we can apply by parts to get the answer. So first function into integration of second function minus differentiation of first function into integration of second function, which in turn will become t e raised to the power minus et plus c. Let us substitute the value of t, and this becomes e tan inverse y into x is equal to, t was nothing but tan inverse y. So tan inverse y e raised to the power tan inverse y minus e raised to the power tan inverse y plus c. Now in order to find the value of constant, there might be something given in the question as it is always given. So the point on the curve is given as 1, 0. So if I put 1, 0, x is 1, y is 0. So this will become 1, 1, 0. So this will become 0. This will become minus 1 plus c. So from here, the value of c comes out to be nothing but 2. Once you have got this value as 2, in the step 4 of this question, we will do the remaining part and get to the answer. So in the step 4, what they are saying is abscissa of the point on the curve whose ordinate is tan 1. So what they want is x corresponding to tan 1. So if I put it here, tan 1, so this becomes e raised to the power 1 into x. This becomes 1 e raised to the power 1 minus e raised to the power 1. And constant term was nothing but 2. So this gets cancelled out and value of x comes out to be 2y. Let us check the options. So you can see that B options comes out to be. If I look into this next 2024, things became little bit more intense because we will have to do some substitutions, then come up with the idea of linear differential equation in x and then solve it. So let us see how we can work this out. So the first step that I thought in this question was to put just tan x as nothing but t, and if I put it so, sec square x dx will be equal to dt. In the next step, you can see that this has become dt. This is still e raised to the power 2y. this is t square, this is t, and dy is equal to, still it is not a linear differential equation in any of the variables, neither x, neither y nor t. So what we can do is we can divide it by t square in the next step. So this will become e raised to the power 2y plus 1 by t and dy. Now you can see that there is a chance of becoming linear differential equation in 1 by t. So what I did was I take 1 by t and put it equal to u. And as a result, this will become minus 1 by t square dt is equal to du. And now we can rewrite this equation as nothing but minus of du plus, and we can divide by dy, plus e raised to the power 2y plus u is equal to 0. And if you want to write it little bit more nicely, du by dy minus u will be equal to e2 raised to the power y. So this is a proper differential equation, linear differential equation in u now. In the next step, what we can do is we can just write here integrating factor, that in this case will become e raised to the power minus dy, that becomes e raised to the power minus y. And if I want to write the solution in the fourth step, it is integrating factor into u is nothing but integrating factor into whatever is on the other side. And if I write down this, integrating factor was e raised to the power minus y into u, and this will become e raised to the power by dy, that is e raised to the power y plus c. And if I rewrite or resubstitute all the old things, this was nothing but 1 by t, this is e raised to the power y plus c, and t was nothing but, in the first step we put it as 10, so it becomes e raised to the power minus y cot x, e raised to the power y plus c. So this is the solution of the differential equation that was given to us. Now interestingly, this is given that passes through pi by 4 comma 0. So let us put pi by 4 comma 0 into it. In place of x, if I put pi by 4, this becomes 1 on the left hand side, and on the right hand side this will also become 1 plus c. As a result, c comes out to be 0. And now what they are asking is what is the value, and now another point is pi by 6 comma alpha. Now corresponding to this we have to get something. If I take this and substitute, this will become e raised to the power minus alpha into cot of pi by 6 will be equal to e raised to the power alpha, and this was already 0. So from here what we have got is the value of e raised to the power 2 alpha, that would be, and this is nothing but root 3. So if question is asking e raised to the power 8 alpha, we will have to take fourth power of this, and this will become 9. So the answer of this question is nothing but equal to 9. Next problem type is nothing but linear differential equation which will get formed after substitution. First we'll do some substitution, then it will become a linear differential equation in x or y, and then we'll solve to get the answer. Now if I look into this 2024 question, a very simple thing to observe would be, if I want to solve this, it is neither linear differential equation in x or y, but if I do some substitution, it will still be solvable. So what I can do is I can take this cos phi written on the right hand side and divide throughout. So this will become sec square y dy by dx plus 2x tan y will be equal to x cube. Now you can see that if I just substitute tan y as t, it will become a linear differential equation. So sec square y dy is equal to dt, and if you divide by dx, it will be dx on both the sides. In the next part we can do this substitution. This becomes dt by dx, and what we have is 2x into t x cube. And now in the next part, if I find integrating factor, this e raised to the power integration of 2x dx, that is e raised to the power x square. In the third step, we can write the answer as integrating factor into t is integration of integrating factor into whatever is on the right hand side, that is x cube dx. So integrating factor came out to be e raised to the power x square into t. This will become e raised to the power x square into x cube dx. Now this is not a very tough equation to solve in step 4, because we can just take x square and put it equal to t. That in turn will become 2x dx is equal to dt. And as a result, and since we have already used t, it would be better to use some other variable like u. So this will become nothing but e raised to the power u 1 by 2, and the remaining part would be x square, that can be written as u du. And now we can use by parts. If I use by parts, it will become first function into integration of second function minus differentiation of first function integration of second function. And now this can in turn be written as u into eu minus eu. So if I write the final answer in the fifth part, it will become e raised to the power x square into t is equal to 1 by 2. U was nothing but x square. So x square e raised to the power x square minus e raised to the power x square plus c. And also let us substitute the value of t. And t in the first step was nothing but 10y. So my final answer looks something like this. Now when you have written the final answer, the usual steps would be there. We'll have to find the value of c, etc. Now they have given that this curve passes through 1 comma 0. So in the sixth part, let us substitute 1 comma 0 and figure out the value corresponding to d. So left hand side becomes 0. Yes, 1 comma 0. Left hand side becomes 0. And the right hand side will become, this is 1 by 2. This becomes e minus e plus c. As a result, c also comes out to be 0. So in the seventh part, what they are asking is the value corresponding to root 3. So let us put root 3 in place of x. So this will become e raised to the power 3 into y, 10y. This will become 1 by 2. This is 3 e cube minus e cube. And you can see that e cube can be cancelled throughout. If I simplify, the value of 10y comes out to be 1. So y is equal to nothing but pi by 4. So option D comes out to be correct. Now type 9 questions are based on reducible to linear differential equation, Bernoulli's equation. What is a Bernoulli equation? You can see that everything on the left hand side looks the same. But if you look on the right hand side, there is a y raised to the power n. Such kind of questions are known as Bernoulli's equation. What is the specialty? When you want to solve them, we will again, it will get reducible. So we can divide by y raised to the power n. And now you can see that if I put 1 by y raised to the power n minus 1 as t, this will become linear differential equation in t. This is the underlying logic, and based on this substitution, we can move on. Now this 2023 is a typical example of a Bernoulli's equation, because if you simplify, you will also be able to observe that what we have is 1 plus x square dy. Let us write dy by dx. This will become xy minus y square. If I bring all the things in on the usual places, so I can write this as minus xy. So you can see that this part looks fine. Major problem is this y square. So in order to make it Bernoulli, and we'll always follow the process instead of a result, what we can do is we can write it as 1 plus x square dy by dx, and we'll rearrange the terms a little bit. So what I will do is I will divide by y square. In fact, minus 1 by y square. So this will become x by 1 plus x square. We have rearranged the terms a little bit. And you have a 1 by y here as well. So we will have a 1 by y here as well. Now once you do so, the substitution looks quite standard in this case. In the next part, you will put 1 by y as nothing but t. And as a result, 1 by y square dy by dx will be equal to dt by dx. And now if I rewrite the whole idea. This was y square. This will become dt by dx and plus x by 1 by x square t is equal to 1 upon 1 plus x square. And this is a standard linear differential equation in t. Now, if you have this, in the next part, third part, we can find integrating factor. E raised to the power integration of x divided by 1 plus x square dx. So here if I want to integrate, I will put this as nothing but u. So twice of x dx will be equal to du. And now this integrating factor in turn will become e raised to the power du by 2u. That is nothing but integration of 1 by 2 ln of mod of u. And that will become nothing but root u. That is nothing but root of 1 plus x square. Now, once you have written this, the fourth step is to get the solution of the linear differential equation. The integrating factor into t is integration of integrating factor into whatever was on the right hand side, that is 1 upon 1 plus x square dx. If I integrate, the integrating factor let us write as root of 1 plus x square into t. Now if I look on the right hand side, it will become integrating factor root of 1 plus x square by 1 plus x square. You can see that if I simplify, it will become 1 by root of 1 plus x square. If I solve it further, the integration comes out to be ln of x plus root of 1 plus x square plus c. Now, in order to find the value of c, what they have given us in the fifth part, they have given us a point 0, 1 on the curve. What they have given is if I put x equal to 0, y becomes 1. So let us put it here. So left hand side will become 1. Now in place of t also let us substitute the value. It was nothing but y, 1 by y. So if I put the value here, it becomes 1 on the left hand side and ln of 1 plus c. The value of c correspondingly comes out to be 1. In the sixth part, they want us to tell the value corresponding to 2 root 2. So 2 root 2 comma beta can be satisfied, and if I do it so, let us see what is the final answer that I am getting. If I put 2 root 2, 1 plus x square will become, this will become root of 9, that would be 3 by beta. And this will become ln of 2 root 2 plus 3 plus 1. So 3 beta, and if I put here ln of 2 root 2 plus 3 plus 1 will come, and if I raise to the power of e, 3 raised to the power beta raised to the power minus 1, and then this will become 2 root 2 plus 3, and this will become e. If you check the options in this question, you can see that the C option. Now let us do one more question, the same idea. So as you see the question, you might be able to see that there is a y plus 1 written at multiple places. So it is a good strategy to put y plus 1 as nothing but t. So if I differentiate dy by dx will be equal to dt by dx. And if I do so, my question then starts looking like this: dt by dx is nothing but t into t e raised to the power x square by 2 minus x. And now if you just open this bracket, the Bernoulli's equation would be self-evident. So it will become dt by dx plus dx is equal to t square e raised to the power x square. Now in the next step, as we always do, we'll divide by t square. So this will become dt by dx into 1 by t square plus x by t is equal to e raised to the power x square by 2, and 1 by t will become, and it would be better if I put minus 1 by t as nothing but u. So plus 1 by t square dt will be equal to du, and do not forget to write dx. So this equation starts now looking something like this. This becomes nothing but u, this will become u du by dx, and this becomes minus of x into u, and on the other side we have e raised to the power x square by 2. So integrating factor in the third part will become nothing but integration of e raised to the power minus x dx, that is e raised to the power minus x square by 2. If I want to write solution, u into integrating factor will be equal to integrating factor into q, that is e raised to the power x square by 2 dx. If I simplify, this becomes integration of dx comes out to be x plus c. So on the left hand side we have u can be substituted by 1 by t minus 1 by t, e raised to the power minus x square by 2 x plus c, and 1 by t can be in turn written as nothing but y plus 1. Once we have got this, it is a matter of time when we find the value of c by some point on the curve. So the point on the curve is 0, 2, 0. So let us put in the next step 2, 0 in it. So if I put 2, 0, this becomes minus 1 by 1 e raised to the power 4 minus of 4 by 2. This will become 2. This is e, the value of x is 2, and this is c. So you can see that the value of c comes out to be minus 2 minus e raised to the power minus 2. And now in the fifth part, they are asking the value of this function. In fact, not this function, the derivative of this function at x equal to 1. So if I want to find the differentiation, this is going to become y plus 1 is equal to minus e raised to the power minus x square by 2 by x plus c. I am writing c, but we will ultimately be able to substitute the value. Now once we have got this, the derivative part is not difficult. We can differentiate both the sides. So for doing right hand side, we will have to use product rule. So division rule. So this will become minus of e raised to the power minus x square by 2 minus x. So 2x by 2 will become minus x into x plus c minus, and then we can again write e raised to the power minus x square by 2. This will become 1 by x plus c whole square. Once you have written this much, now if I substitute the value in this as x equal to 1, let us see what do we get. So, and I have made this correction. So it will become e raised to the power, minus sign is fine. This will become minus 1 by 2. This will become plus if I put x equal to 1. This is 1 plus c. And this is plus e raised to the power minus 1 by 2 into 1 by 1 plus c whole square. This is what we are getting. And now in the numerator part, we can clearly see that after doing this calculation, the value of dy by dx. So what I have done is I have put x equal to 1 in this, and hence we have got this expression. So e raised to the power 1 by 2 can be taken common. This will become 2 plus c by 1 plus c whole square. C we figured out was nothing but minus 2 minus 1 by e square, or e raised to the power minus 2, same thing. So if I add 2 in the numerator, 1 by 2, this is minus 1 by 2 was fine. But if I write c plus 2, it will become minus of 1 by e square. Here if I put 1 plus c, so 1 will become minus 1 by e square whole square. And as a result, now if you simplify, this is 1 by 2, minus 1 will come, 1 e square will come after LCM. This becomes e square plus 1 whole square. So it is minus e raised to the power minus plus 3 by 2 by e square plus 1 whole square. Now let us check the option. If you check the option, A option matches. Now the next problem type that we are going to move into is exact differential equation. See a differential equation that looks like this. M is dx equal to n dy. Here m is also a function of x and y. and n is also a function of x and y. So the test is, if I find partial derivative of m with respect to y, it should be equal to partial derivative of n with respect to x. Here it is x, so we are writing y. Here it is y, we are writing x. Now I totally understand you don't know partial derivative, and functionally speaking, there is no need to know all of this. What you need to know is this. Observe, let us say that this equation is not fitting into any of the earlier modes. So it is not variable separable, it is not homogeneous, it is not it is not linear differential equation and any of the reducible forms. All you need to do is then go into the question and see whether you are able to generate a product rule or a division rule out of it. And once you do this, it will become a variable separable. It is very simple, don't need to make it any complicated. Just try and figure out product rule or division rule and your question will get solved. Now let us look into a very simple question that came in 2023 based on this idea. So what they have given is, they have given us this equation, and after this there is some other things that we will have to do. First try and solve this equation. So if I want to solve this, now you can see that here you are able to generate a product rule, and these two ideas would be very useful. That is d of xy. This you will find quite often, x dy plus y dx. And d of y by x. It can also be x by y. There can be something else in place of y by and y and x. This is again the same thing that I just told you. So x dy minus y dx by x. So this we are going to use quite often. There are some substitutions of this or variations of this that we will also use. So once you have observed this, now the solution becomes very simple, because now this can be written as d of x by y, and now it becomes variable separable because dx is fine, but on the other side d of xy is there, and this is what we have. Once you have got this, when we are integrating, we'll consider x into y as one variable. If you are not very comfortable with this, I will advise you to put that equal to t for doing the integration. So this will become dt by 1 minus t square. Now this has become very simple because you know this integration. There is nothing complicated in this. So this will become nothing but, and I would take minus sign common, and this can be written as t square minus 1, which in turn will become 1 by 2a ln of t minus 1 by t plus 1. And or if you remember the other formula 1 minus t square, that also works. There is no issue. What I am saying is, instead of doing all this, we could have done in the first step only. So you can directly write this integral as nothing but minus 1 by 2. Same thing, but we are directly applying the formula xy minus 1 by xy plus 1. So psychologically we are assuming the same thing. Rest everything is fine. And also we could have integrated on the left side. So whatever is feasible. If this is feasible, do this. If this is feasible, do this. So x will be equal to minus 1 by 2 log of xy minus 1 by xy plus 1 modulus plus c. So this is the solution of the differential equation. Now after this, whatever steps we had done in the earlier question will remain same. So what they are saying is, if x equal to 1 intersects the curve, this is the curve that was given to us at y is equal to 2. So the line x equal to 2 intersects the curve at y is equal to alpha, then find the value of alpha. So they have given us a point 1, 2 on the curve. So if I substitute 1, 2 in the step 2, so 1, 2, x will become 1 and y is 2. So 1 into 2 will become 2 minus 1, this will become 1, and 2 plus 1, 3 plus c. So from here, if I want to get the value of c, it is 1 plus ln of 1 by root 3, and this in turn can be written as c is equal to 1 minus ln root 3. This is what we have found. Now in the third part, they want us to find the value of alpha. Now alpha is there corresponding to x equal to 2. So let us put x equal to 2 here. This will become minus 1 by 2 ln of 2 alpha minus 1 by 2 alpha plus 1. And let us not forget to put the modulus sign. It is very important. Now plus c will come. C we have figured out as nothing but 1 plus 1 minus 1 by root 3. 1 minus ln root 3. Now we can simplify it in this manner, and after doing those steps, you can check the calculation and option A matches. If I look into this next 2024 question, it says that if we have the solution is already given to us, they want us to find the value of alpha plus beta, and we have been given the differential equation like this. So what we are going to do, again, we are going to observe that x dy minus y dx is given, and then you have xy into x dy plus y dx. So all the usual suspects are there, x dy plus y dx. So all we need in this first part is if I can multiply and divide by x square. So this will become x dy minus y dx by x square. And then this becomes xy d of xy. This is already there equal to 0. And now this part can be written as d of y by x. And then if we can take the other one on the other side. So minus xy d of xy. And see, this is very peculiar thing that will happen here quite often. It will not always be straightforward. You will have to readjust the terms. So if I simplify this, this becomes d of y by x by y by x is equal to minus dxy. So now it becomes a proper variable separable. We can integrate. This is ln of y by x common. This is minus xy plus c. This is what we are getting. And this is the first part. Now, what they are saying is, if you write the solution, it looks something like that. So, for that, we'll have to get the value of c. For getting the value of c, they have given in the second part that the curve passes through 1, 2. So, let us put 1, 2. So, ln of 2 will be there. This is 2 plus c. So, c comes out to be 2 plus ln 2. So, if I want to write the solution in the third part, we'll write the c here. So, ln of y by x common is equal to minus xy plus 2 plus ln 2. This is what we are getting. And now what they want us to write an equation in terms of y and x. So we can do that. We can do that if I take ln on both the sides. So if I raise it to the power of e. So if I raise it to the power of e, let us see what do we get. So this will become ln of y by x. This will become e raised to the power minus xy plus 2 plus ln 2. So this will become y by x. And obviously there is going to be a mod. So do not miss out onto the mod part. And then this will become e raised to the power minus xy plus 2. And e raised to the power ln 2 will become 2. Now let us see what they are saying. What they are saying is xy minus beta is there. If I take it on the other side, this will be mod e raised to the power xy minus 2 and mod of x into 2. If I compare, you can see that value of alpha is 2, beta is 2, and then alpha plus beta will become 4. If I look into this 2022 question, it is little bit more cryptic compared to other question. Now the first step in such question is, first we'll have to separate the terms. So 2x e raised to the power x by y square dx plus y square dy minus 4x e raised to the power x by y square dy. This we can write. And now see, this term is already sorted because the variable is already separated. In the first two parts, we'll have to put some brain. So if I put 2x e raised to the power x by y square minus 4x e raised to the power x by y square dy plus y square dy, it will be equal to 0. Now the important thing here to understand is this very simple idea. If I have to differentiate this, what will happen to this differentiation? It will be x by y square, and if I differentiation 1 by y square, it is going to become, let us put derivative here, it will become dx into y square minus 2y dy into x. and then in the denominator we'll have y raised to the power 4. Now if you closely observe, we don't have y square or one excess of y. One thing I can do is I can reduce 1, 2. So next step should be very simple. Remove this 1, 2 from here. Make those 2 here because we want to generate this form. And you can see that there is y square dx. Here we have a dx. For that, let us multiply and divide by y. So this will become y square. The next part will become, so y square dx would be there. In the next part, you will have 2xy. Again, we have multiplied by y and dy. And now we can see that the y that multiplied, we are also dividing with it. E raised to the power x by y square we can write. Plus y square by 2 dy is equal to 0. One more thing I can do is I can divide the whole equation by y. So y square will come, what we want is y raised to the power 4. So we'll divide by y cube. So that this becomes nothing but y raised to the power 4. As a result, we'll also have to divide this by y cube. If I simplify this is nothing but derivative of e raised to the power x by y square. And this part becomes nothing but dy by 2y is equal to 0. And now we have separated the variable. In the next step, we can integrate. So dx by y square, e raised to the power x by y square. This is integration of d by y. And if I simplify this, in the next step, we have got our answer. So answer becomes e raised to the power x by y square plus 1 by 2 ln mod of y plus c is equal to 0. Now let us go back to the question. Question says that if I put y is equal to 1, x is equal to 0. So it plus y is equal to 1, x is equal to, it passes through 0. If I put 0, 1 here, I will be able to get the value of constant term. So this part will become 1. This one will become 0. So the value of c from here comes out to be minus. In the next part, what they are asking is the value of when we put x, when we put e, y as e. In the fourth part, if I put y is equal to e, what will be the value of x? So let us put y is equal to e. So this will become e x by y square. So this will become e square. This will become 1 by 2. If I put y as nothing but e, this will become 1. C was minus 1 equal to 0. We can see that e raised to the power x by e square. This is equal to 1 by 2. So x by e square will be equal to ln of 1 by 2. So x is nothing but minus e square ln. This is what is the answer that we are getting. Now let us check the options. You can see that D option matches. Now type 11 is equations reducible to exact differential equation. So a very typical form is asked, dy by dx is equal to ax plus by plus c. And now here in the first term, you will find the same coefficient but with different sign. So here it will be there, and the next of the terms can be separate. There is no issue with the remaining terms. So I can write a dash y plus c dash. There is this combo that you need to watch out for this kind of questions, because we'll see what happens when this kind of combo appears in the next question. If I talk about this 2022 question, you can clearly see the same combo getting generated here. And these are the two important things that we need to notice. Now, as a result, if I simplify, let us see what will happen. If I cross multiply this, so what we will have is bx dy, cy dy, and a dy. On the other side, we have ax dx minus by dy dx and a dx. Now, if I bring all the terms on the same side, and this is very important for exact differential equation. So this term and this term will try and grow. So this will become by dy. And then you have cy dy plus a dy, and then minus ax dx minus a dx is equal to 0. Now, if you very simply observe in these first two terms, because of this nature of the pairing, b will get common and it will become d of xy. So you can see that just by doing this, Now all the terms can be easily integrated. It is very simple integration after this. So this becomes minus of ax dx minus a dx. And because of this nature, this has become now a variable separable. In the next part, we'll integrate. So if I write the same thing and put integration sign over it, I will be able to get an answer. So this will become bxy plus cy square by 2 plus ay minus ax square by 2 minus ax is equal to, and this we can write as a constant. See, you can write constant on left hand side, right hand side, it largely does not matter. What they are saying, this represents a circle passing through 2, 5. See, if it is a circle, then there are two important things for something to become a circle. One is, in this 2-degree equation, the coefficient of x square should be equal to coefficient of y square. So that should mean c should be equal to minus a by 2. C by 2 should be equal to minus a by 2. So we have got the first relation. And another thing is, we can't have this x square term, so b should be equal. So if I put these two conditions into place, what I have got is minus a square. So you can also replace this by c by 2. I will write c by 2. And let us not write this as c dash. Let us write the c, instead of that, write this as c dash. This we can write as c by 2. And what we have is x square plus c by 2 y square. We have next is nothing but minus ax. That can be written as nothing but c now. So plus cx minus cy is equal to constant. Now there are two things we don't know. One is the value of c, another is the value of c dash. If I want to find this, what they are saying is, this passes through a point 2, 5. So 2, 5, if it passes through 2, 5, and rest of the thing passing through, yes, ABC are constants. So once you figure that out, you will be able to get an answer. So if I put here 2, 5, so this will become c by 2 into 4 plus c by 2 into 25 plus c into 2 minus c into 5 is equal to c dash. If I simplify this, on the left hand side, what we have got is nothing but, this is 29 c by 2. This will become minus 3c is equal to c dash. So if I simplify, this comes out to be 623c by 2 will be equal to c dash. So now the answer will depend on the ratio of c and c dash ultimately. So if I take some value of c, let us say that c is equal to 2. Correspondingly, c dash will become 23. And as a result, this equation that we have written here, this comes out to be x square plus y square. C came out to be 2. So 2x minus 2y minus 23 equal to 0. So we have got our circle. Now they are saying that there is a point 11,6. What is the shortest distance? The shortest distance is always d minus r mod. D is nothing but distance from the center. So the center is here minus 1, 1, and the radius is root of g square plus f square minus c. So that will become here nothing but 5. So if I figure this out, this is nothing but 12 square plus 5 square. This is d, and this radius is nothing but 5. So if I figure out this value comes out to be root 13. This root will become root 169 will become root 13 minus 5, and as a result, if you subtract 5 from that, answer comes out to be 8. Let us check the option. You can see that B option comes out to be correct. Now, type 12 questions are based on geometrical application of differential equation. Now, there are two types of questions I have seen in this category getting asked. One is based on the idea of tangent and normal, that is connected with application of derivatives. This is one idea that we are going to use. So, using this, we will form a differential equation and then solve it to get an answer. This is one idea. Another idea is when we use the idea of tangent, length of normal, subtangent and subnormal. This is another idea that we can use. So for the first idea, you already know the basic theory. For the second idea, I will want you to remember this diagram. So if you remember this diagram and apply it without even thinking what the question is, you will always get the answer. So let me quickly draw the diagram, and you can remember this diagram as such. So let us say this is a tangent at a point. So if I draw normal, this will become normal. Now this point is nothing but x1 comma y1, or easily we can remember this is h comma k. Now this angle is theta, and then tan theta can be written as dy by dx at this point h comma k. So once you have this, now what you need to do is draw up a perpendicular from here. This point will become n. This is p, this is t, this is s, that is n. So just remember this diagram, because as the name goes, p here, the length of tangent would be nothing but pt. So this is nothing but pt. Length of normal is nothing but pn. Length of subtangent is st, and length of subnormal is sn. Now either you can remember these formulas that are given to you, or remember this diagram. So in this diagram, if I go in this PST, and if I want to find subtangent, I will apply in this triangle tan theta. So tan theta would be nothing but SP. SP here is nothing but height of this point, that will become k. So can be written as k by st. So st can be written by k by tan theta, and tan theta is nothing but dy by dx. So we can use this kind of ideas in this triangle to figure out. I do not need to remember the value, I just need to remember the diagram. It is very important. Now this angle is theta, this will become 90 degree minus theta, and then we can do the same thing there as well. Using this relationship, value of PS and the triangles, we can get all of these values very simply. Now let us look into the problems that were asked on this idea. Now this is the first category of question where it is linked with AOD. So what they have asked is the concept of tangent and normal. In the first step, what they are saying is slope of the tangent to a curve yx. So what they have given is dy by dx is equal to 2y by x square. You can see that this is a variable separable. We can separate the variables, integrate and get the answer. And if I do so, this will become 1 by 2 ln mod of y. This will become minus 1 by x plus constant term. Now in order to find the value of constant term, what they are saying is this curve passes through the center of this curve. The center of the circle would be 1, 1. In the next step, let us put 1, 1. The left hand side becomes 0. Right hand side becomes minus 1. The value of constant comes out to be 1. So if I want to write the equation, it would be nothing but 1 by 2 ln mod of y is equal to minus 1 by x plus 1. If I simplify and write this can be written as x ln mod of y. This will be equal to minus 2 plus x. This is my final answer. Now let us check. You can see that option, and this is 2x. So instead of this, I could have written minus 1 into 2. So 2 should be outside. So you can see that D option matches. Now if I look into this next 2023 question, there are two parts of the question. One, they are talking about a tangent to a curve and certain conditions are given. And then there is a second part of the question. In this, they are using the value of k. So we'll have to solve this question into two parts. Let us solve the first part first. In the first part, there is a curve on which we have drawn a tangent at a point P. Let us consider this point as h comma k. Ultimately, I will substitute h by x and k by y. The slope of this tangent dy by dx at h comma k will become the slope of the line. And if I want to write the equation of this tangent, it is y minus k by x minus h is equal to dy by dx at h comma k. Moving further, I can put x equal to 0 and get the value of point B. And I can put y is equal to 0 and get the point A. Any one would do, so I am putting y equal to 0. In fact, I am putting x equal to 0 and getting the value of y. So y would be nothing but k minus h dy by dx at the point h comma k. Now in the next part and the second part of the question, not exactly second part, there is a condition given in the first Wally equation only, that is PA by PB. Now we can also figure out the value of x in similar manner. So what I can do is, in the same part for the point A, I can put y as a 0 and this will become minus k by x minus h is equal to dy by dx, or the value of x from here would be nothing but h minus k by dy by dx at h comma k. So if I want to write a point B, that will be nothing but 0 comma, and I am replacing k by y and h by x now to generalize things, and also I am going to do the same thing with P also. I can also write this point as x comma y before moving to next step. So if I do so, this point comes out to be y minus x dy by dx, and you can see that everywhere I have done this. This is my point B, and similarly point A will come out to be nothing but h minus k. In fact, in place of h, let me write x minus y by dy by dx comma 0. So this is nothing but point A. We have point B and point A. In the next part, let us apply section formula. So if I apply section formula, if I do it for the x coordinate, x would be equal to nothing but this PA into PB is in the ratio 1:k. K into the x coordinate of A, that would be nothing but k into x minus y by dy by dx plus 0 by k plus 1. And similarly, if I do for the y coordinate, y is going to be nothing but 0 plus y minus x dy by dx by k plus 1. We can consider either one of them. I am considering the second part. And now if I take this, it will become a differential equation. Y times k plus 1 is equal to y minus x dy by dx. This y and 1 will get cancelled out. And now we can see that we have variable separable. So this can be written as dx by x with a minus sign and dy by y. Now can be easily integrated. Let us integrate it. And what I am getting is ln x, and there is a k here. Let us write k. And there would be a k multiplied by k is equal to ln y plus c. Now it is given in the question clearly that this curve passes through two very important points. One is 1, 1 and another one is nothing but 1 by 10, 100. Now we can use both of them to find the value of k. This was the purpose of doing the first part, and in the second part the value of k will be used to solve the equation. So if I put 1, 1, you can see that c comes out to be 0. And if I put 1 by 10, 100, so this part will become k into minus, this will become plus ln 10, and this is 2 ln 10. This will get cancelled out and the value of k comes out to be equal to 2. The first part we have successfully solved. Now let us move to the next part. Now in the second part, we have been given a function, equation that looks like this: e raised to the power dy by dx is equal to k, that is nothing but 2x plus 1. If I write the value of dy by dx, it will be log of 2x plus 1. So if I want to get the value of dx, it is log of 2x plus 1 into dx. And now we can integrate this. For integrating the right hand side, what we will do is we will put 2x plus 1 as nothing but t. So what is happening? Twice of dx will be equal to dt, 1 by 2 will come. This is ln t dt. And now what we can do in the next part is, we can just integrate it. So applying by parts, you will have ln t into t minus t plus c. This is the equation, and let us substitute the value of t. It is 2x plus 1 this multiplied by minus 1 into 2x plus 1 plus c. So this is what we are getting. Now once you have done this, what is given in the question is, if I put x equal to 0, y will be equal to k. So in the next part, if I put y is x equal to 0 in this, it comes out to be k is nothing but 2. The curve passes through a point 0, 2. Let us substitute here. So this will become 2. This is 1 by 2. ln 1 will become 0. Minus 1 will remain. And from here, again I am getting 1 plus c. So you can see that the value corresponding to this will become minus 1 by 2 plus c. Hence the value of c is nothing but 5 by 2. Once we have this value as 5 by 2, next part is to find the value corresponding to 1. In the fourth part, let us put x equal to 1 and see what do we get. If I put x equal to 1, the value of y corresponding to that would be nothing but 1 by 2 times log of 3 minus 1, and this will become 3 plus c, that is nothing but 5 by 2. Let us simplify it further and write the final answer. So becomes 1 by 2 ln 3. This will be 3 by 2. And then if I subtract, this is minus 3 by 2. So minus 3 by 2 plus 5 by 2 will become 1. So this is the value of y that we are getting. Now once we have got this value, the next part says that 4y1 minus 6 ln 3. So if I put here 4 times this, so in the fifth part 4y1, so 4 into this will become 6 ln 3 plus 4 minus 6 ln 3. This will get cancelled out. Answer comes out to be 4. Now type 13 questions are based on the intersection of idea of differential equation and area. Now let us see what JEE has asked on this problem type. If I look at this 2021 question, there are 3 parts of the question. What they are saying is there is curve 1 given in the question. This is my curve 1. It is given the form of a differential equation. I need to get it. This is the first part. Second is I have been given a curve 2. I have to get this. This is my second part. And then once I have got both of these curves, I need to figure out the area enclosed between them. Okay, so I will have to solve 2 differential equations and then find the area enclosed between them. So let us start systematically. So if I start with the first curve, and if I look into this, it is clearly a homogeneous differential equation. So the trick is very simple. You divide by x square, and if you do it in the left hand side, it is y by x dy by dx. It becomes y by x whole square minus 1. And now the trick is very simple. Put y by x is t or y is equal to tx. And if I differentiate, and this we have done a lot of times now, will be equal to t plus x dt by dx, which if I simplify becomes 2t into t times x dt by dx is equal to t square minus 1, or 2t square plus 2 tx dt by dx is equal to t square minus 1. This will get cancelled out, and what we have is got 2tx dt by dx is equal to minus t square minus 1. And now this is a variable separable. 2t by t square plus 1 dt is equal to minus dx and can be integrated to get an answer, which if done will become nothing but ln of t square plus 1 mod is equal to minus mod of x plus constant. Now the question says that this curve passes through a point 1, 1. So if I put 1, 1 here, y by x will also become 1 and ln of mod of x will become 0. So c is equal to ln 2. And if I write this curve, what is the final form that we are getting? Let us also write that. So my final form comes out to be equal to ln of y square by x square plus 1. Mod part I can bring it on the left hand side, becomes plus mod of x is equal to C that was equal to ln2. This becomes y square by x square plus 1 into x is equal to 2, which if simplified becomes y square by x plus x is equal to 2. Or in other words, can be written as y square plus x square is equal to 2x. Or it is an equation of a circle that looks like this: x square plus 2x plus y square is equal to 0. We have a minus 2x here. Once we have understood this, that what we have got is a circle. This can be written as x minus 1 whole square plus y square is equal to 1. This is the first part. Now I will have to do this process one more time. So let me remove this part from the left hand side and do the same process one more time. So if I start with the next curve, this next curve is given as nothing but 2xy by x square minus y square dy by dx is equal to dy by dx. So this is again a homogeneous equation. We will again write it in terms of 2y by x, 1 minus y square by x square. And in this part, now what we can do next is, we can simply put y as tx, and this we did earlier also. Dy by dx would be equal to t plus x dt by dx. If I simplify, this is 2t by 1 minus t square. This will be t plus x dt by dx. If I take it on the left side, it becomes 2t minus by 1 minus t square minus t is equal to x dt by dx, which in turn simplified comes out to be t plus t cube by 1 minus t square is equal to x dt by dx, and this can be written in terms of variable separable as dx by x is equal to 1 minus t square dt by dx. See, now we already got the equation of the earlier form. Now we will integrate this and get the answer. If you simplify this, and you will be able to get the other equation that will become x square plus y square is equal to 2y. Similar integration is there. There is nothing very complicated. So this is what we will get, which will simplify itself into x square plus y minus 1 whole square equal to 1. Now once you have done that, you have got the equation of the curve 1. We have got the equation of the curve 2. Now let us come on to the area bit. Now you can very clearly observe that if I plot both of them, it is going to be, now we are doing the third part, that is nothing but the area part. So you have got one equation that looks something like this. And if I look into the other one, that looks something like this. The center would be at 1, 0, 1 and 1, 0. If you find the points of intersection, it is also simple. This is 0, 0. This is 1, 1. Now once we have got this, what they are asking us is to find the area enclosed between these two parts. That is nothing but this area. This is what the question is asking us to find. In order to make things simple, you can see that because of the symmetry in the question, if I draw a line y is equal to x, so this is a line y equal to x, it will pass through these 2 points because this is 0, 1, this is 1, 1. So if I could figure out just half of that, that would be more than enough. Now this upper curve is x square plus y square is equal to 2y. So its center is nothing but at y minus at 1, 0, 1. And this one is nothing but x square. In fact, we already did x minus 1 whole square plus y square equal to 0. The center is at nothing but 1, 0. If I can just figure out this part of the area and multiply by 2, I should get my answer. And for doing that, I can find this area 2 times integration from 0 to 1 root of, now this curve earlier when we wrote was equal to y square is equal to 2x minus x square. So this will become root of 2x minus x square minus x, that is nothing but from y is equal to x dx. Let us integrate this and get the answer. So integration, for doing integration, we will have to write this as root of 1 minus x minus 1 whole square dx. And this next integration becomes nothing but x square by 2, 0 to 1. Now, once we have written it in this manner, let us figure out the integration and get the final answer. So, you can see that for doing this first integration, and now let us write it separately. So, I am writing it separately 1 minus x minus 1 whole square 0 to 1 dx. And now here we can put x minus 1 is nothing but t. Dx will be equal to dt. And this becomes, if I put the limit, this becomes minus 1 to 0 root of 1 minus t square dt. We have a direct formula for this. This can be written as nothing but 1 minus t square. It can be written as nothing but x by 2, that is t by 2, root of 1 minus t square minus 1 by 2 sine inverse t minus 1 to 0. And if I substitute the value, let us see what do I get. If I put 0, this becomes 0. If I put minus 1, it becomes 0. So this is inconsequential. If I put 0, this limit becomes 0. If I put minus 1, it becomes minus pi by 2. So this becomes minus plus pi by 4. So now we have figured out the value. So this is nothing but 2 times pi by 4. And this will become nothing but minus 1 by 2. If you multiply by 2, answer becomes pi by 2. Therefore, let us look into the options. So you can see that B option satisfies. So it is an extremely long question. There are two parts. First, to find the first curve by getting the first differential equation, then get the second curve by integrating or doing the second differential equation, then find the area after that. Now, if I look into this 2024 question says that there is a curve y is equal to yx lying in the first quadrant such that area enclosed by this line, which is a tangent to the curve, and the coordinate axis is given to us. So first, earlier we had to find the curve first, then do the area part. Now we have to combine or connect the both ideas in between. Let us see that. So what is happening is, let me draw a rough diagram for you. Let us say that this is my curve. Then there is a tangent at a certain point, and this point can be considered as x comma y. This is a point P. And the equation of this tangent is given as nothing but capital Y minus small y is equal to capital X dash minus capital X minus small x. This is what is given to us. So if I want to find the area, that is this area, I will have to find this x-intercept and y-intercept respectively. And if let us say that this is x-intercept, this is y-intercept, then the area is going to be half of AB. And this is what is given to us, and from here our next part will start. So let us first figure out the value of A. And this point would be nothing but A comma 0. If I put A comma 0, this will become 0, this is y. This becomes y dash of x, and this is nothing but A minus x. So from here the value of A is nothing but x minus y by y dash. And similarly, if I want to find the value of B, I will substitute 0 comma B. And if I do it so, this becomes B minus y is equal to y dash of x is nothing but 0 minus x, or B is nothing but y minus x y dash of x. Now from here the second part of the question starts, that is the connection of area and then solving differential equation. In the second part, what they are saying is, if this area is equal to minus y square by 2y dash of x plus 1, and now this is equal to half of AB, that would be nothing but x minus y by y dash of x into y minus x y dash of x. If I multiply this, let us see what do we get. So first things first, let us simplify this y part. So if I simplify, this will become y dash of x. This will become 2 here. And on the right hand side, now what is left is, if I multiply, xy will come. Then x is square y dash of x. And then if I multiply the second part, y square by y dash of x. And then if I multiply, this will become plus xy. What we can clearly see from here after this simplification is, this term is getting cancelled out. And this becomes a very doable kind of a equation. 2 is equal to twice of xy minus x square y dash of x. Now, in order to solve this in the third part, what we will have to do is we will have to write this y dash is nothing but dy by dx. So 2 is equal to 2xy minus x square dy by dx. If I simplify it further, this can be written as nothing but 2 dx is equal to 2xy dx minus x square dy. Now you can clearly see that this is potential to become dx square y. So we are using the idea of exact differential equation. What I have done, let me write it down one step to explain you more. I have written this is 2 d of x square minus x square dy. So in order to generate a d of x square by y, I will have to divide by y square and multiply by y square. And what we have is 2 dx. So if I simplify this, let us see what do we get. So 2 dx will be equal to d of x square by y into y square. In order to get this term, I will have to divide by x raised to the power 4. Now if we integrate, we should be able to get the answer. Left hand side is quite simple. This becomes 2 into x raised to the power minus 3 by 3 with a negative sign. And if I have this on the left hand side, if you want to simplify things, you can write t here. This will become t square and integration becomes minus 1 by t plus c. Now if I substitute the value of 2x cube minus 3, this is fine. This will become minus 2 by 3 x raised to the power minus 3. I can write a c here. Minus 1 by t was nothing but x square by y. So this becomes minus y by x square. C, if you want, you can keep it writing on the right hand side. It is no problem. Now I can simplify this by writing y by x square is equal to 2 by 3 x raised to the power minus 3 plus c. Now the question says that we were at step 4. We can say that it passes through a point x equal to 1, y is equal to 1. If I put it here, this becomes 1. This becomes 2 by 3. This is c. The value of c comes out to be 1 by 3. In the fifth part, for getting the value at x equal to 2, and if I put 2 here, let us see what happens. This becomes y by 4. This becomes 2 by 3 into 8 plus 1 by 3. So this is simplified. This is y by 4. This comes out to be 8. This will become 10 by 3 into 8. And if I simplify it further, y will be equal to 10 by 6. That would be equal to 10 into 2. Answer comes out to it.
If you like this video, you will also like PracBee's unique one-on-one last mile journey program. In this program, we sit with the student, understand their preparation till this point of time. And based on that, in step 2, we write a customized planner just for you to help you optimize your marks in JEE Mains exam based on whatever preparation you have done. In the step 3, we sit with you one-on-one by a set of faculties aligned by PracBee and help you implement the customized plan that we wrote for you. Students have come to us with limited no or good preparation and all have been able to score their marks to a large extent. Ashish, using this program, was able to improve his fortunes by lot, starting from 95 percentile in JEE Mains attempt 2 to getting selected for mechanical in IIT Madras. Ditya, over a period of time, was able to crack into JEE Advanced using this program. If you think that this seems interesting to you, click on the link below in the description, fill the required details and somebody from my team will get in touch with you.